Hi, this is a lesson for Year 10 Higher Mathematicians. The topic is histograms, and this is Lesson 8, Histograms 2. The histogram shows the time in minutes for a garage to repair some cars during 1 week. Note the class interval widths are not equal. Find the number of cars repaired during the week. Now, hopefully from last lesson, we remember a formula that told us how to calculate frequency density. We were told that frequency density is equal to the frequency divided by the class interval width. And the reason we calculated the frequency density was that if we drew the bars to the height of the frequency, the histogram became distorted by the class width. So what we needed to do was calculate the frequency density, which is basically an average across the groups. And this allows us to compare one group with another more effectively and more fairly, basically. Now, what we want to do today is to use this formula to work backwards and solve problems if we're given the histogram and we want to find out things about the group's frequency table it came from. And we do this by firstly rearranging this formula. So if frequency density is equal to the frequency divided by the class width, it makes sense that the frequency density times by the class interval width must be equal to the frequency. So, in other words, if we take the frequency density and multiply it by the class width interval, that will give us the frequency of the cars repaired in a particular class interval. Now, you'll notice that from this histogram here, what that means is if we're timesing the frequency density by the class interval width, what we're doing is basically finding the area of the bar. All right? In other words, the area of each of these bars represents the frequency of the cars repaired in that particular class width. So, if we do that for each bar in turn, that means that 1 times by 10 is going to give us 10 cars were repaired, took between 0 to 10 minutes. 2 times by 10 gives us a frequency of 20 cars repaired between 10 and 20 minutes. 4 times by 5 gives us a frequency of 20 cars repaired between 20 and 25 minutes, and so on for the other groups. 1 times by 15, that's 15 cars repaired, and 0.5 times by 20 gives us 10 cars repaired there. So if we want to find the total number of cars repaired during the week, we simply have to add up all of these frequencies which tells me that in total 75 cars were repaired during the week. So let's have a look at this example here, again getting slightly trickier. The histogram shows the speed in miles per hour of random cars being speed checked. Again, note the class interval widths are not equal. You have to complete a grouped frequency table and find the estimated mean speed. Right then, so to get started with this, I'm going to do something very similar to what I did for the little starter activity, but I'm going to write a little bit more information down to help me complete the grouped frequency table. So if I just write down here, this is the class interval width and the frequency density here. So I can see from this that the first class interval width is from 0 to 30, therefore the class interval width is 30, and the frequency density is 0.1. By multiplying these two together, that's going to give me the frequency, which is 3. For the next one, from 30 to 40, that means the class interval width is 10. Frequency density is 0.8. 10 times by 0.8, 8. 40 to 45, class interval width is 5, frequency density is 4. 5 times by 4 tells me that the frequency is 20. 45 to 50, class interval width of 5, frequency density of 3. 5 times by 3 is 15. 50 to 60 is 10. 1. 10 times 1 is 10. And 60 to 80 means the class interval width is 20. Frequency density is 0.2. 20 times by 0.2 is 4. So I have found at this stage all of the frequencies for each of the separate class intervals. Now what I'm going to do is transfer these across into the table to complete it as I've been asked to do, and then I'm going to use that table to help me find the estimated mean. So just to save some time there, these are the two columns I had on the previous page, the class interval width and the frequency density. Here's the frequency that I've calculated using those values, and here are the class intervals that I've written down. Note again the use of the inequality signs. That means that for this table that 30 miles per hour would go in this group here, and anything between 30 and up to 40 would go in this group. Okay, 40 would go into this group, not in this group. Okay, so I've done the first bit there, complete the grouped frequency table. Now what I want to do is find the estimated mean speed. Now if we think back to lesson 2 in week 1, where we had to find the mean from a grouped frequency table, we know that this means we need to do a couple of things. We need to take the midpoint of each group and multiply that by the frequency. I'll explain why once we've done that. So here we go. This is the midpoint, which I'm just going to call x. So the midpoint of this group here from 0 to 30, the midpoint is going to be 15. From 30 to 40, the midpoint is going to be 35. 40 to 45, it's going to be 42.5. 47.5, 55 and 70. Now what we're going to do is, because we know that we've got 3 cars that were measured, had a speed that measured somewhere between 0 and 30, we don't know whereabouts between 0 and 30 that speed was measured. So we estimate that those 3 cars were travelling at 15 miles per hour. So if we wanted to find the total speed of those 3 cars, we would do 3 times by 15. And we're going to write that answer in this column here, f of x. Okay, so if this is the frequency and this is x, f of x 3 times by 15 gives me 45. Similarly, we're going to assume that we've got 8 cars here travelling at 35 miles per hour. 8 times by 35 is equal to 280. We're going to assume that we've got 20 cars travelling at 42.5 miles per hour. And so on for each of the other groups. And if I add all these up, in other words, I want to find the sum of f of x, I get a value of 2717.5. Okay, and this value here represents an estimate of the total speeds of all the cars. Right, to find the estimated mean, I need to take the sum, the estimated sum of all the speeds of the cars and divide that by the number of cars. How do I find that? Well, I find the number of cars by doing the sum of the frequencies. If I add all these here up, that tells me I have 60 cars that had their speeds recorded. So to find the mean, or the estimated mean, that is going to be equal to 2717.5 divided by 60, which gives me a value of 45.3 miles per hour, the estimated mean speed of those 60 cars.